Hey everyone, today I'm going to talk about Chapter 7, Section 5, which is all about scale drawings. It can also be about scale models. The whole idea is that the model or drawing is proportional, keyword proportional, to the real thing. For example, if you were to take a picture like this and have your picture enlarged, everything would be enlarged proportionally. It wouldn't be like you just stretch the face and things would get wonky. So it's everything keeps proportional. And yes, those are my kitties. Okay, so key ideas: a scale drawing is a proportional two-dimensional drawing of an object. That idea, like someone had blueprints of a house or a building, and things of that nature. A scale model is a proportional three-dimensional model of an object. So this would be like if you made like a little model car, or if they did a model of a building that people were drawing. And scales are what give the ratio that we actually are going to compare things. So things are either going to be enlarged or reduced is the correct language. Okay, so it's the model over the actual thing. It's written this way, but we can calculate it in proportions, kind of in fractions. When I was learning to drive, we would figure out how long it would take to get somewhere based off a map. You guys can just like punch something into a phone and it tells you how long, but I would know, like, if this long was 100 miles and it was this far on the map, it would tell me how long it would take to get somewhere. So we're going to use that idea to practice this question right here. So finding an actual distance. Okay, so I have this little map here. And it tells you right here is the scale that they used, okay? And that's always the first ratio in your proportion. And remember back in Chapter 5 when we talked a lot about proportions, I was always telling you to put your words first. And this is how we can organize things. So if you look at our words here, we have centimeters and miles. So I know that it is centimeters over miles. All right, and this ratio here is always the first ratio in your proportion. So I know that 1 centimeter is the same as 50 miles. And you guys, 1 centimeter is about the length of your fingernail. And obviously 50 miles is, from here to well past Los Angeles. So that's a big difference. That's a big enlargement. This is a, little map of Michigan, and we know that a state is not this small. Okay, and so what we're trying to figure out is figuring out the distance between Cadillac and Detroit, Michigan. If I look for those here, here's Cadillac, and here is Detroit. So we're trying to figure out the actual distance between these two cities in Michigan. Okay, well, we know it's not, 1, 2, 3, 4 centimeters, so we're going to use our ratio here. 1 centimeter is 50 miles, and then I have it measured here. It's about 3.5 centimeters, and we know that centimeters go here, and our unknown is the distance, the miles here. Proportion, cross multiply, 1 times x is x. 50 times 3.5 is 175. We were solving for miles here, so we know that it is about 175 miles. All right, so using the information just to set up a proportion, and if you have your words first, it's really, really helpful. Okay, let's try a couple of these. So right here I tell you that a map has a scale of 1 inch is 4 miles. Well, that's going to be the first ratio in your proportion. We are talking about inches over miles. It's 1 inch is equal to 4 miles. It says you measure 3 inches between your house and the movie theater. Well, 3 is here because it's inches. How many miles, that is our unknown. And so you have your proportion set up because you had your words first here to help you. Cross multiply, 1 times x is x, 4 times 3 is 12. So it is about 12 miles to the movie theater from your house. Okay? Go ahead and pause it really quickly and try part B. It says it is 17 miles to the mall. How many inches is that on the map? All right, pause it and give it a try. Okay, hopefully you paused it. We're going to use our same scale here. It is inches over miles. Our first ratio is the one that's given. Okay, that's your scale. And it says it's 17 miles. Well, 17 goes down here where the miles go. Our unknown is our inches. Cross multiply, 4 times x is 4x. 1 times 17 is 17. Divide both sides by 4. X is equal to 4.25. So it's 4.25 inches or 4 1/4 inches on the map, however you want to write it. So hopefully you did okay with that one. And that's using a scale when you have 2 different units of measurement. Okay, your next key idea is dealing with something called a scale factor. This is when a scale is written without units, okay, without units, or when the units are the same. Okay, so you'll see in a minute things look like this. Like that's a scale factor. And this just means that if your model is, 1 inch, your actual thing is 8 inches. So your actual thing is 8 times the size as your model. It doesn't matter if you're talking about inches or feet or centimeters. It just means that because your scale factor is 1 to 8, your actual thing, whatever it might be, is 8 times the size. So if the scale factor was 1 to 10, then it would be 10 times the size, okay? So that's the idea of scale factor. So let's look at this first example here. It says we're going to find the scale factor. So we have to do a little bit of work. Okay, so it says a scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. Okay, so we're always going to put whatever the model is over the actual thing. And the actual thing is this statue here, and the model would be exactly that, the model, okay? Well, I know that the model is 10 inches tall and the actual monument is 100 feet tall. Well, that's a good scale right here because I have 2 different units, but we're looking for scale factor. Remember, scale factors without units or when the units are the same. So the first thing I'm going to do is make my units be the same. This is 10 inches and this is 100 feet. I know that there are 12 inches in a foot, so I can change this to inches. And how do I change 100 feet to inches? I would just multiply this by 12. Okay, so I know that 10 inches and then 100 times 12 is 1,200 inches. And look, we are on our way. We have the same inches, inches over inches. But this can simplify. I could divide both of these by 10 and I get 1 over 120. And then if I want to write it as my scale factor, I would write it this way. And you can see that I've taken my units away. And it doesn't matter if this was going to be feet or inches or whatever. I just know that this actual statue is 120 times the height of the model that they provided for us. Okay, so we're going to try a couple, and these ones get a little funky, but I think you guys will be okay. We're going to find the missing dimensions using this scale factor of 1 to 8. That means here's your model, here's your actual thing. The actual thing is 8 times the size of your model. And what you can see here is the height is in inches for the model and the actual is in feet here. So we're going to have to do a little bit of converting in the end. But because they gave it to you in inches, when we solve it, it's going to be in inches, okay? So let me get to my right page. I'm going to come over here to number 1. Model over actual. There's my words first. My scale factor is 1 over 8. My model is 168. My actual height of this statue, I do not know, so I put my x, cross multiply. You get x is equal to 1,344. And this is in inches. Why do I know it's in inches? Because that is what we had here and that is what I solved for. However, I want it in feet. I know that there are 12 inches in a foot, so I can do some converting. So if I take this and I divide it by 12, that would give me the correct answer. 1,344 divided by 12 is 112, and the answer is 112 feet. Okay, here is number 2. Let's work it out together. I know this can be kind of confusing. Model over actual, we're only going to do a little bit of it. The scale factor is 1/8. Again, that means the actual painting is 8 times as wide as the model of the painting, okay? So 1/8. I don't have my model dimensions, but I have my actual dimensions of 200 meters. And because I have the meters, that means I'm solving it in meters. This is 8x is equal to 200. Divide both sides by 8. X is equal to 25. I solved it in meters, so x is equal to 25 meters. However, my answer wants it in centimeters. I know that there is 100 centimeters in 1 meter. And if you didn't know something like that, a simple conversion, you guys, just Google it. It's okay. It's what everybody does. So 100 centimeters is 1 meter. So if I have 25 meters, I just need to multiply this by 100. And that would get me 2,500 centimeters as my answer. Okay? We're only going to do a little bit of this. You'll be okay. Go back and review this to help you out. And remember, whatever unit you have is what you've solved for. So make sure, sometimes the units are the same, sometimes they're different. You need to do a little bit of converting, okay? And you can use Google to help you out with that. All right, hope this helps. Bye.